Okay, so I believe we can start. Okay, so welcome to the lecture about Apache Camel, and basically we are going to go over how to develop some enterprise services with it. So my name is Adnan. I'm a software engineer in Takta, and I'm working primarily in Java enterprise world for over 6 years. And okay, let's start. Okay, so who had some experience with Apache Camel here? Did anybody work something? Okay. Well, not yet quite popular around here, but I presume it's going to be. So basically, what's Apache Camel? Well, it's open source Java framework under the Apache Foundation with quite large community. That's what's mostly important for frameworks for any kind of technology, is that it has great community, big community, and is constantly expanding. It's quite stable tool and quite very useful. Okay, so what does it do? So basically, what Apache Camel is some sort of the integration framework, middleware, that helps you transport certain messages from one point to another point. It can be either internal, inside your services inside your application. For example, so certain classes with beans or etc. And also those endpoints can be external resources like certain REST services, I don't know, databases, files, or etc. How did Apache Camel came to exist is there. I mean, people before had a lot of problems, like solving certain issues when they have certain endpoints and they want to transfer certain information from one endpoint to another endpoint. And especially in Java, when you need to strictly design the class, the object that comes out from one endpoint, and it needs to be exactly in the second endpoint, and also first endpoint needs to know about the second endpoint in most cases. And what happens is sometimes those endpoints do not match with that definition of that object of that message, so you need somehow to change that message, to adapt the message to the receiving endpoint, or even you need some sort of the transportation to decide if those two endpoints cannot know about each other, or etc. So there were a lot of issues about that. So two guys wrote a book based on their experience. What they did in this book called Enterprise Integration Patterns. They just collect those certain design patterns for that messaging, for that transportation of those messages, and they wrote about them inside the books and how to solve them and how they named them. They just wrote some designs about it, and so people wrote the Camel based on that book. So basically, what exists there and the solutions that exist there are present in Apache Camel, of course in own design. So Apache Camel is, of course, written in Java, so that means that the definition of everything inside that you can do it. You do it in specific languages, so you write it either in Java, so you use that functions from that framework inside your Java code, or it has, of course, supports for different frameworks like Spring, so you can write it down in XML to find those, we call it that roads from one endpoint to another endpoint, or if you want to do something with that message, you can also write that in XML or in Java language. And of course, it does have support for some other frameworks and other language inside it for the JVM. So that's great support for Groovy, for Scala, etc. So let's actually. Apache Camel is quite lightweight, so basically what it does is solves that problem regarding integration of different endpoints. So what else to do here besides just show you several examples. So for now, I will just go over some examples that are most commonly used or most commonly you are going to have in the practice. So when you define the route, you want to bring it from one endpoint to another endpoint. So you define from where. In this case, you write down, okay, you name this route or start endpoint for this route. You give some name. In this case, it's country code list, so I just took it from our project. So nothing special, and you have this something called component. I will explain later on a bit what exactly components are, and especially what direct means. And what's mostly common is that you write the ID for that route. So when you have several routes inside your application, it's always good to name them. Otherwise, this name will be used to identify those routes. Reason why it's good to name it in some way. You don't need to use slash, I just use slash for some convenience, but you can even have spaces around here. So it's great for logging. For the Apache Camel also has great support for GMX, so you can see those routes inside the Visual VM or inside Java Mission Controllers, etc., or some other tool. And what else you want? The most simplest solution is actually to bring from one point to another endpoint. So you want, this is quite understandable what it means, bring it to some bean named receiver service and define it to which method to call it. Of course, this means that this route expects that somebody who sent that message to this route, that message is equal to the one that this method expects. So, but for this example, you'll presume that is such case. So this is most simplest example. By the way, this is functional Java code. If you place this, if you have already dependency or you introduce the dependency of Apache Camel core, this will compile. So this is how the route definition looks like, and that's it. It is, as you can notice, it's quite Unix-like pipeline. So each part of that pipeline it will work actually as Unix pipelining. So everything that comes in one segment, each segment of that pipeline can receives a certain object, and it also produces certain object. So what it produces in this part will end up in the next part of the pipeline. So, and of course, the point of the routing is actually to tamper with that object. Okay, so for the convenience, I didn't place any XML-based examples, just because it's usually quite large. So what I did here is something that is mostly prepared for Spring Boot support. So Apache Camel has great support for Spring Boot. So if you want to define those routes inside your Spring Boot applications, the only thing that you need to do is actually to have certain component, certain bean that extends this route builder that comes from the base dependency of the Apache Camel core. You can name it whatever you want, and you need to override this configure method and place your routes inside it. So what you can basically do here is to place as many routes as you want. One thing is your naming needs to be unique. In some cases, you need to care a little bit about the the order of the routes, because it goes, of course, from the top to the bottom. But those are pretty much edge cases. So basically, you can just align them here as you want. The only thing that you might want to take care about is the exception handling, because exception handling, I'll show you later how it is defined, can be defined per route or just globally for the full Camel context. By the way, those routes are bound inside the Camel context. Its functionality is pretty much similar to Spring's application context. You can have several those contexts that work independently inside one application, or even inside one JVM instance. And there are options that those routes can communicate between all those Apache Camels. So basically what you can have is if you have several applications inside one JVM, they can communicate directly with the help of the Apache Camel. So this, of course, most important, as I mentioned, you have this route definition where it's entry point. So how can you call that entry point? Of course, you can call directly from certain classes from Java code. Is in cases of Spring on Spring Boot, you just need to inject this endpoint, and there's a Spring Boot starter for Camel that will set up everything that you need, and you just need this class, this bean, and you just call that. You just use this method. In most cases, you'll use this method sendBody, where you define which route and to the object. So now, when you call this route, you send this certain objects. I mean, it expects just something that's of type object, so it can be whatever you want, and the route definition will do something with that. In our previous case, you just gonna bring that object to that method in that bean. So another options for invoking that route is external. You can define it from external sources, like you set up the Apache Camel to be its REST services itself, so it doesn't need something between external sender. That you don't need to set up certain controllers, something like that. You can set up it directly in the Camel, or it can be files, databases, triggers, or it has great support for timers for Quartz, so you can schedule location of the routes. So, as I mentioned before, it has options for the exception handling. So if something happens here, in the runtime, you can define how to handle it. In most cases, you want to bring it to some logger, to some logging service, or to ActiveMQ or something like that. It has also great support for ActiveMQ if you are using it. You just define what happens on that exceptions. Of course, you need to enter the part of the pipeline of the exception so it doesn't go further. And you just, in most cases, you want to just say, okay, it's handled so it's not propagated further. Okay, so that's basically what we had, what I mentioned, that I will explain later what this direct is and what components are. Basically, what defines the route is actually, of course, starting endpoint, which can be different sources, internal and external, as I mentioned before. And how it is, this route is evoked is also defined by this part, where you define, when you say, okay, I want to evoke this, I want to evoke the route, which is direct. Direct means that it evokes synchronous, as a synchronous operation, so in one thread. And whatever evoked this will wait for this route to finish. If you say it goes to the bean, it means the Apache Camel that is going to search for the bean. So this component actually knows what to do with this information. Here, everything is pretty much defined in your URL-based system, when you place question mark and then you give certain properties. So if you want to invoke the file, you just define the component. So the component of Apache Camel called file, and then you place certain information, file location, what you want to do with that file, and what kind of operation you want inside that file, to want to delete it or copy it or whatever. And so for basic communication components for that is, if you call the route, you can call it direct, as I mentioned, synchronous operation. There is SIDA, probably it's pronounced SIDA. It's based on this type of architecture, staged event-driven architecture, which means that we'll call asynchronous. The call for that route will be asynchronous, so it doesn't necessarily means it's going to wait, but you can set up it to wait the results if you are expecting a certain result, and it goes in the blocking queue way of waiting. So, and invocation of threads. So whatever happens after this, when you define this with this component, it will be done in complete new thread, and you can set up the limitation how many threads you want to invoke. You can limit those kind of stuff. So, but these two components are only mentioned. These two components are designed only for one camel context. So if you are using a Spring Boot application, that means that it will automatically set up the camel context inside that application. One this context will be present there, so it can communicate only inside that camel context, or in this case of Spring Boot, if you are using default behavior, it means that only rules inside that application. If you want to communicate with external application, or external camel context inside your application, if you have several of them, in most cases you will just use one context for your one application. Then there are these two options. They are only limited to the Java JVM instance, so you cannot communicate outside of it. You have this VM, which behaves also as this one. It's asynchronous operation, or if you want that direct, if you want to wait for that other context or other application to finish it works, you have this direct VM. Okay, so in previous case we have one start point for the route, and you have only one receiver. Of course, in practice you probably want to have multiple receivers, so you want one message from one place to end up in several receivers. It may be several beans, files, databases, or all of that. So basically what you do is you just place more tools. You just pipeline those tools. Or you can write them inside one tool and just, like in var args style, you can place them in one tool, or in this, or maybe it's even better in readability to have multiple tools here. And as you can see here, we are invoking another route. We are sending the object what's ended up from here to this route, or you have this component which will directly log under this name and with this level, and you want to show about it. Okay, so why show about it? Because this object that goes from one part of the pipeline to another is object that contains several information, including with the body. That's the object that you set with that template or another resource. You have headers, you can have attachments or different kind of information about that route. So several options there, and you want to show that, or whatever you want to show, headers or something like that. So basically here, but thing is, it will be done in sequence. So when this one is finished with that message, you can also change the message. So if this method has produced something, it has a return type, return object, that object will become this body, which will end up in this route. What this route produces will end up here. If you don't tamper with that, or you don't return anything here, the message that came here will continue going down there. So, but in cases of multiple receivers, you probably want that this one message goes to all those receivers without any, if this one does something with that message, you don't want that to end up here, you want the original message here. So what you do is just add operation multicast. So this one will send the original message to each of these. So this is one of the examples of the design patterns for integration in that book. So what does is just implements that. So what does this multicast is still going to do that propagation of that message to all those services, to all those components is sequential. So, but the tempering here will not affect the what ends up in others, but it's still going to be one thread. So what you want is just to add here option called parallel processing, which will just create more. It will create threads for each of those receivers. With one limitation, the default value that default number of threads that's going to create this 10. So, but you can give it an option to increase that or decrease it or whatever. So another specific pattern for integration is that when this sender sends that message, you want to do something with that message. Those operations include like you want to reach that message, so you want to add certain more information, you want to filter certain information for that message, you want to, I don't know, but in any case, do something with that. You, of course, Camel has option for that. When this sender sends that message, you do something with that, and then you send to everything else. What you do is you have this option for process. I mean, I mentioned before that those tools can also return certain object. You can temper here, but there is a specific there is a better option to do that is with this process method here, because if this method returns something, that will end up in the body. So you still don't have that easily access to the headers or other parts of that object that goes from the one component to another. But inside the process, you have access to here, because this process allows you to tamper with that object, which is called exchange. And so what it expects is that you actually implement this functional interface. You can either do it inline here, or you can just outwire certain bean or create certain class exactly here or a little bit before from. So what is expected here to do is that you implement this processor functional interface, and instead that you get access to this exchange message. This exchange message exactly is that thing that goes from one part to another part in that pipeline. And this exchange contains all those information that you can tamper with, which you actually goes around. As I mentioned, you have access to the header and body. Body is the object that you are usually this message itself. Headers, I mean, you know pretty much about general HTTP communication. It's pretty much the same here. Of course, there are several more, including attachment, route information, etc. And you can now temper. When you finish the tempering, you can just say get in and set body, and you will replace that. Okay, so in this case, you can actually temper. The thing is, you will receive object, so you need to cast it to what you are expecting here and then temper here. So another possibility is that you want just one receiver to receive the message based on some certain property, certain header, certain value inside the body or something like that. You just do the same. You just need to extract that information that will help you decide where to go. You have this option, this choice function that then you just order events, and you then inside that you also have the access to that exchange object, and you extract certain information that will help you decide to which endpoint it's going to end up, and this is syntax for that. And of course, at the end, you have otherwise if no condition is met here. So, of course, as I mentioned, it can be exposed as the REST service. So there is an option for that. So you just use this function here, REST starting point, and then Camel will set up everything for you. Just one note, it will set up under the path. In the path it plays Camel inside the URI. So, but you can change that or fix that. I mean, Camel will be before here, say. So you can change that. There are options for that. And this is syntax how do you set up it. Okay, you place the root path, and then you just line other things you need. You just set up which get method. Let's, for example, get method, post methods, delete method, or something like that. You can set up different things, like you can set up, okay, expecting this this type of message, etc. And this is pretty much self-explaining thing. This is the best part about Apache Camel, and what makes it better than other other possibilities for integration is that it has quite a great syntax. It's Unix-like pipeline. The syntax for this in, let's say, Spring integration will be like 4 or 5 times bigger code, so quite much better syntax. So besides exposing a REST service, it can call REST service. So what you need is certain triggering point. You then call REST. You set up headers, necessary headers. It also works great with the Spring security. So you can easily set up the GVT tokens, etc. And you just set up headers, and you call the certain method, and this tool will receive the result, which will be placed in that exchange object. But what it brings back is the string. So you need to convert that string to something, in most cases to string, and then you can marshal it inside the object. Apache Camel has great support when it comes to the, let's say, for the JSON for XML conversion. In this case, I use the list JSON format, so when it receives JSON list of objects in JSON or in JSON, and in this case, I will convert it to the list of the contributors. So basically, one line to do that, and I send it somewhere else. So this is more simplest way of doing this. And of course, since I received list, I can split it and send to this being one by one. And combining with the multicast, I can, with parallel processing, I can do parallel threading processing of the parts of the list. Okay, so besides these prepared solutions for marshalling the receiving objects, you can also, if you receive string, you can use this option tokenize to split it by certain new lines by this character or some regex or something like that. And you can use this option streaming to stream it to this option, to this endpoint. There is parallel streaming, there's even options for delaying, or there's a bunch of options. So since I'm a little bit out of the time, I'm going to hurry up. One of the most used cases is that you can save certain, use the route to save something, to tamper with the database, and with the Spring Boot support for the GPA. This is it. Basically, in this case, if entity comes with the predefined ID, it will update that object. It will know how to update that object, which table, which line, and everything. So basically, 2 lines to save or update based on what the object that came to this contains here. So, and of course, there's option for GDBC, so you can write plain SQLs to do something with your receiving objects. And one of the great things is also Apache Camel has great line of supports for triggers, including this one. If we used this here to save something inside this entity table, in this case, thanks to the support for GPA, this route will be automatically triggered as soon as something is tempered in that table, and you can do something like that to notify someone or something like that. And one final example that I prepared is file handling, something that we mostly are using, especially when we are dealing with Excel files and PDFs or something like that. This has perfect support. I mean, you can just give it, define you are using this component called file. You define it with use this option here, but you can write the path here around here. But in this case, you can tamper with the path in the runtime. But the reason why I included this one is because I want to make sure that you are using this correctly, because Apache Camel has a little bit strange behavior by default. When you are reading certain files from certain folder, it will first create a subfolder called Camel, and will copy those files there, and then do something like that with those files. But if you place this node equal true option, it will not do that. It will just do something with that file directly from the source. in this case, of course, by default, this is a trigger. So if somebody saves or creates files in that folder, this route will be triggered automatically. You can, of course, change that option. We mostly use even if you update something, you have options to trigger this route to update the endpoint. It can read those new information and then send further to the route. So quite a lot of options like instant reading, instant triggering, or triggering by a certain time or something like that. Pretty much this is it. And of course there is option to create files. Pretty much the same. Looks like if it doesn't, if it's in certain tool, it means it's going to either create a new file or update that file. And of course, a bunch of options what to do with that file. So generally, Apache Camel, as you could see, it has beautiful syntax, very easy to use. If you watch those routes, imagine how many codes you would have to write those. And what is most useful for us when we work with clients, we can actually show those routes. And even if they are not programmers, they will understand what's going on here. So it's the documentation by itself. And especially for those who love Unix, they will be they can easily understand this, so they will instantly love this syntax. It has around, as you can see, I showed several components around here. Currently, I think there's almost 300 components. It has support even for Facebook, for Twitter, for emailing, you can create your own components for your internal, if your company has some internal software that's you're using for something like notifications or something like that. You can create a component that will do something with that software just in one line. So quite useful. And best part, not only with this framework, what makes certain frameworks great is actually support. It's actually not only the stability but support. It's a great community, and Apache Camel does have a great community. So if you are searching for certain ways to, if you identify that you need to solve certain integration problem, you can easily find millions of solutions on the internet with Apache Camel on different ways or something like that. So quite great software. We are using it for quite a while now. So what we noticed is that we reduced the code both much large. Also, the number of lines in the projects are quite smaller now because we transfer a lot of classes just in those couple of lines. And especially those options for parallel processes are great, helpful, especially if you don't not quite used to do something concretely. That's great support for that. And so, are there any questions? Okay, you can always contact me on various social networks. I'm always ready to help. So, thank you very much.